Everybody knows, after the MVTec Innovation Day is before the MERLIC release. Therefore, welcome to our MERLIC 5.5 release webinar here from rainy Munich and our MVTec headquarters. I just checked the numbers of registrations and I'm very happy to see that we keep on rising in attendees here at our release webinars. So thanks very much for your rising and continuous interest in MERLIC. My name is Marcus. I'm part of MVTec's marketing team. And once again, I have the honor to guide you today through our webinar. But before we start, we do some organizational information. At first, you will receive a follow-up mailing shortly after the webinar where you get the recording and the handout. And second, I want to recommend the Q&A session we have after the webinar. So if you have any questions, make sure to write them during the webinar in the GoToWebinar chat. And now let's face today. Today we talk about things like communication, color, and counting. Well, obviously we talk about it in a machine vision context. So this is why I'm very happy to welcome now our experts for today on stage. Here are Ulf and Jenny.
Hi, Marcus.
Hi, guys.
Hi.
Do you want to introduce yourself quickly to the audience?
Yes, sure. My name is Ulf Schulmeier and I'm product manager for MERLIC.
And my name is Xinjin. I'm an application engineer.
Wonderful. You guys are excited about the new release?
Yes, sure. There are top new features.
That sounds like a good spoiler. So I would say it's time to set the table with the live demonstrations. And we are back in 10 seconds. So see you very, very soon. We are back with the live demo. See you in a minute.
I hope you can see our PowerPoint. Very good.
Can you switch to the slide? Okay, let's start. Before we start with the new features, I would like to point out a few advantages of MERLIC. And this is real customer feedback I heard at the MVTec Innovation Day, mid of February. So this is not marketing, it's real feedback. And the very first advantage of MERLIC, I can show you here, it is hardware independent. And this means that you can use industry cameras which support the following standards: GeniCam, GigiVision, and USB 3 Vision. And there are many companies that produce such cameras, and this ensures availability of the devices and reasonable. I see we have a little issue here. It's better? Okay, thank you. So once again, there are many companies that produce such cameras, and this ensures availability of these devices and reasonable costs. The second important advantage of MERLIC is it runs on Windows, on good old Windows, because Windows is administered very easily. So if you go to your IT guy and ask for help for controlling MERLIC, he says, okay, it's a Windows version, no problem at all. It's not a smart device, which you do not know if there any ports are open. It's good old Windows. The next advantage is that your image processing solution with MERLIC can be changed or expanded at any time. Additional cameras or further steps in quality in control can be added flexibly. And the next advantage is that MERLIC offers both. In addition to classic rule-based machine vision application, deep learning applications can also be easily implemented. And the free deep learning tool, with it, you can train your models and integrate them into MERLIC. So these are very good advantages. But now let's have a look at the new features. It starts with a new deep learning functionality with deep learning. And this is a new concept tool in MERLIC 5.5. It allows users to count the number of trained objects while also detecting their positions. This function is very robust against scaling and orientation. And unlike other deep learning-based methods, this feature can be trained with minimal labeling directly in MERLIC. So here are the advantages, because we have an example included, and this example explains how this tool can be used. So counting is beneficial for a lot of applications. Think about product counting, traffic flow monitoring, contactless counting, inventory management, and approximate object localization. So this new concept tool boosts your efficiency of object counting, particularly in scenarios involving deformable materials or bulk goods. So, Qin, where can we find this new feature in MERLIC?
Very good question. So I will take over the technical insight of this new feature. You can find this tool under the concept tools processing. And as Wolf already mentioned, we also provide an example to show you how to count the bottle tops with deep learning based counting. And you don't need the deep learning extension because the training runs in MERLIC. It works with only MERLIC S license. In this slide, we will use the example images to build a simplest deep learning based counting. At first, we need to find the tool in the tool library. We type count and drag the correct tool in the tool flow. As you can see, there are also counting tools based on traditional image processing methods. And now the tool is being inserted. After that, we can put an image into the training window and zoom the image to be ensured that your label quality is very good. Here we provide different regions to define a region of interest on your object. In this example, we only train our deep learning model with one object and apply the training data with all the default parameters. Let's have a look at the performance. Also, this tool can be used with multiple training images. And the training lists several seconds to minutes. Now the training is done. We can make the image size properly and start several single execution to see the performance. So as you can see, we only need two tools, and you can build your counting application with deep learning functionality. And the performance is really very good. It's not 100%, as you can see in this image. A bottle top is covered by a bottle, which means only a small part of the bottle top is captured from the camera. In this way, we have also tips for you to improve the deep counting functionality. The first tip is how to train a model with multiple objects. Here, we can put a new image in the training window and apply a new label. If we want to label another object, we can put the image again in the training window and do another label. And in this case, we can build some difficult cases in your training data set so that your training is robust against some different difficult use cases. And besides, you can also adjust your training parameters. So the second tip for you is to adjust training parameters to increase the robustness against orientation and scaling. The orientation parameters and scaling parameters can also be set in the tool. And the third tip is to adjust inference parameters, such as minimum score or maximum overlap. So this is the tips for counting with deep learning. And now Wolf can start to introduce you the new feature.
Thank you, Yin. So with the next tool, you can recognize colors with MERLIC. And this tool is a feature request from one of our customers working in the automotive industry. It detects strained colors in various conditions, as you can see in this shown cable example. If the selected color has not been trained, then it will be displayed as unknown. The training of the colors within MERLIC allows defining the desired color classes for the detection. And an example is also provided here to explain how this tool works. So this tool can be used in many use cases, like part verification or selection, verifying proper cable connections, or confirming the installation of the correct resistor. Further applications are conceivable in the food industry or in plastic recycling. Yin, do you have additional information for us?
Yes, I have some technical insights and also a practical part for you. So in this slide, you can see the recognition color tool can be also found under the concept tools processing. And the example, recognize color of cables, it is used to recognize different cables. And here we show you how to build your color recognition application in just a few steps. As usual, we need to find the correct tool. After that, we should define the region of interest on image to tell the model that we want to recognize colors on these regions. And in this case, we want to recognize colors of the 5 cables. So we define 5 regions on the cable. After that, we can add a training image, draw an ROI over the color you want to recognize. To get a better variation range of the color, you can also draw more than one ROI to train your color recognition model. But in this example, we show you the simplest usability. And as you can see in the video, we also need to give the number of the color. So after that, we applied the training data. In 1 second, the training is done. And we can start several single executions to have a look at the performance. And as you can see, even if the color of the cables are changed, it can also recognize all the trained colors. And color recognition tool can also recognize the unknown colors, even if the color is not trained. So the tip for using color recognition is you can apply your image with matching tool. And in this way, we can provide a robust performance, because if the position of the cable changes, the matching tool will align the image. So this is the technical insight of color recognition tool.
Thank you, very interesting. So the next feature, MERLIC 5.5 extends its connectivity capabilities with the introduction of a new TCP socket plugin. Socket communication is very common, for example, in robot control or between PLCs and smaller machines, for example, conveyor belts. This plugin features the ability to use a highly customizable text-based protocol. You can now configure specific, simple ASCII messages that contain only the information relevant to the application. These messages can be easily processed by devices that do not support complex protocols, such as OPC-UA. So, Yin, please give us more details.
To give you more details, please assume an application with me together. Assume that a robot want to communicate with a vision system. The robot will send some commands to the vision system, such as start single job with the parameters or prepare recipes with the recipe ID, etc. Then the vision system will do the corresponding job and send a result back to the robot. The robot receives the results from the vision system, and this is the application. One challenge is different robot vendors expect different formats of the commands. But in this way, we can configure the formats in the TCP socket plugin. Here, we want to introduce you some advantages with TCP socket plugin. The first advantage is we provide different commands in this plugin. Use these commands, you can control your vision system with the suitable behavior, such as start single job, start continuous job, prepare unprepare recipe, etc. And in general, a message of the command contains of the command itself, the parameters, and sometimes also an end string. Assume the robot 1 from the first vendor expects a space between parameters. Parameter 1 space parameter 2. And the second robot expects a column between the parameters. Parameter 1 column and parameter 2. The second robot expects an end string semicolon. And the fourth, the fifth, each robot vendor expects the different commands. So we can configure these different commands in this plugin very easily. We can configure the command separator for incoming message. We can configure the decimal point character for incoming message. We can configure the terminator for incoming message, the start character, and the terminator for outgoing message. To establish the connection, you only need to give the IP address and the port number. The next advantage is the content of the messages can be configured, can also be activated and deactivated. Here, we show you an example with the result ready item. You can enable the event or disable the event for your application. And if your robot expects a very detailed information, you can write the format here with result ready, result ID, recipe ID, job ID, the time, the content itself, etc. But if your robot only expects the result itself, you can also delete all other information and give the content itself. Last but not least, the socket plugin is available as a separate package. You can go to our software manager and download TCP socket plugin separately. After introducing 3 new features, you may be very excited to have a look at it in the practical part. And now I will explain the demonstration at first, and after that, we will show you the demonstration. So here, if you attended our innovation day on the middle of February, you will remember we used this setup to establish the connection between a PLC and the vision system via OPC-UA communication. But now we implemented the setup to establish the connection via TCP socket plugin. And as you can see, we will show you 2 applications with count with deep learning and color recognitions. So the PLC will send a command via TCP socket communication to vision system and tell the vision system, now please activate count with deep learning application, please start a single job, please switch the application. Now let's show you the demonstration. In this demonstration, we will combine the previous 3 new features of MERLIC 5.5. Deep counting, color recognition, and TCP socket plugin with this setup. A short introduction of this setup: we have illumination, we have a camera to capture images, and we have a Siemens PLC at 7500. Also, we prepared a TIA-POTA program to establish the connection between Siemens PLC and MERLIC via TCP socket communication. Now, let's start MERLIC RTE setup. Connect, and let's have a look at the recipes at first. In the recipes, you can see we imported the two recipes, deep counting and color recognition. Besides, we set the recipe of deep counting by default so that this recipe can be loaded automatically when starting the MERLIC in the RTE mode. So now let's start MERLIC RTE. And you will see the deep counting front end will be loaded automatically. And at the same time, we can also start the MERLIC communicator. Here, the TCP socket plugin is started, and we also configured the IP address and the port number to establish the connection. Now let's have a look at deep counting. And the first task is to count the bottle top. Let's put several bottle top under the camera. The number is 4, is correct. And we can also make the case more difficult. It's also correct. Or let's put one bottle top above the other ones. It's also correct. It's quite easy, isn't it? But assume if it does not work very well and we want to adjust the parameter in the front end again. In this case, we can activate the manual config. And now the application is go back to the front end mode, and we can adjust the parameter directly here and to put it left and right to find out a correct parameter for the application. And if I think the parameter is okay, we can do some test by starting a single execution or starting a continuous execution to put some different cases. So now we can switch the manual config to the activate mode, and now the application is in the process integration mode again. And we can control the vision system with our PLC by pressing this button. So now let's show you the second application. We switch the second recipe, color recognition, by this button, recipe 2. Now the color recognition application is loaded. And we put the bottle tops back and check the cables. We put a cable under the camera, press start single job, and we will see we defined the order of 3 cables. The upper one should be red, the middle one should be blue, and the lower one should be black. And this cable is the correct one. And if we put another cable under the camera, the 3 blue, and you will see the red one and the black one are not correct because they are blue, and the middle one is blue is correct. Therefore, the overall result is also not correct. And we can also put another cable under the camera. Okay, okay, and okay. Very good. and put another cable. It also works very well. And we can also change the position of the cable. You will see on the image, the position of the cable is not changed because we applied a matching model to align the image. And in this way, the color recognition works stably. So this is the demonstration of deep counting, color recognition, and TCP socket plugin. Thank you very much. I hope you can see our screen. And Wolf,
thank you.
It's your turn.
Okay, thank you. So the next new feature is high dynamic range imaging. MERLIC 5.5 includes new methods for HDR, high dynamic range. This feature extends the existing Merge Images tool, now equipped with HDR functionality, to combine images of varying exposures into a single HDR image. High contrast differences can now be handled, eliminating overexposed and underexposed areas in images. And even the most challenging lighting conditions can be accurately represented and analyzed. This opens up new possibilities for a variety of applications, including the measurement of reflective surfaces and increasing the dynamic range of an image. So there are two methods of merge images. High dynamic range. This combines 2-byte images to a 16-byte image with higher dynamic range. And exposure fusion. This is a similar method to HDR, but without tone mapping. So Finn, please show us some use cases.
Of course. So here are some images with high exposure time and lower exposure time. If you can see, with each image, we cannot get the full information of the image content. But using the HDR technology, we can combine the image and have the whole feature from this image. And here is another example. In the left-hand side is high exposure time, and right-hand side is lower exposure time image. And here is the HDR image. If you can remember our MERLIC webinar 5.4, we introduced you a feature acquisition sequences. This feature defines a series of actions for a device, and we also showed you a live demonstration with HDR. At that time, we implemented an extension tool for HDR, but now you can get this functionality in MERLIC directly. Besides, acquisition sequences can also synchronize different devices. And in MERLIC 5.4 webinar, we also showed you these possibilities. We can configure a light controller to synchronize different illuminations and the camera. In this case, the illumination 1, the dome illumination is on. We get an image under this light condition. After that, the dark field illumination is on, and we get an image under this dark field illumination. And in this way, we can observe our object with different conditions. And this light controller is a non-streaming device. Regarding the non-streaming devices, we have also an improvement. How to select the non-streaming devices in MERLIC? We improved the usability. Now you can select whether a device should deliver images or not. If you connect a non-streaming device with your MERLIC, and you can only select don't acquire images from this device, and in this way, it's not counted to a camera. And only streaming devices will count as camera in the MERLIC license.
Okay, thank you, Xin. So there are further improvements, but we have just the time to show a few of them, especially in the MERLIC communication section. And for this, I hand over to Yin again.
Thanks, Ulf. So the first section of improvement is we have improved some usabilities in the communicator. The first improvement is we update the version of all the communicator plugins. In the previous MERLIC version, MERLIC provides the result ID and some job ID, these built-in IDs. But from the MERLIC 5.5, MERLIC also provides the user-defined ID, such as measurement ID and part ID. For example, if we apply an anomaly detection, each image has a measurement ID. But in each image, there can be multiple defects, and each defect has a part ID. And in this way, you can have the flexibility to control your results of the vision system. After that, we have also the improvement of delivering the timing information, such as acquisition time and processing time. The next advantage is for the REST plugin. We can check messages on the arrows page. In the previous MERLIC version, we don't have this arrow option, but now if something happens, you can check the error directly in the REST plugin. And regarding the REST plugin, we also provide you some examples for the REST API clients with different programming languages. So these are the improvements of the communicator. And now I will hand it over to Wolf, and he will tell you some other improvements.
Thank you. Another very important point is that we listen to our customer feedback. It helps us to get better and better. The following changes are made by requests of you. The behavior when starting MERLIC Creator and when creating a new MV app in MERLIC Creator has been improved. From version 5.5 onwards, the image source tool is inserted automatically because using the image source manager is the recommended way for image acquisition in MERLIC. As you can see here, the configuration of image sources can be accessed directly from the image source tool or via the runtime environment. I need this.
Sorry.
No problem. Once an image source is configured, you can use it in different MV apps. The next improvement is, previously, MERLIC tools were deleted without any further confirmation by the user, which could lead to accidentally removed tools. Now, the user must confirm that the selected tools should be deleted to avoid deleting any tools by accident. Some applications icons have changed as well for better recognition, and this allows the applications to be distinguished, especially in the status bar. And last but not least, your feedback counts. We have integrated a survey in the start dialog of MERLIC, and we are very excited about your feedback and look forward to your participation. So this slide concludes our presentation. Thank you very much for your attention.